Bismillah ar-Rahman ar-Rahim. And we started 4.3 and we reach these problems. Okay, finish this one. So let me continue. Now, which of the following is always true? And I know A the correct answer, so let me do it backward. The maximum value of x equals square in this interval. Notice this interval is what? Open. So if you grab the function, this is the function, this is x-axis, y-axis. Okay, so it's -3. At 3, I have 9, but open. At -3, the same thing. So the function is not equal to 9, since it's an open function. So we don't have maximum. No maximum in this case. So this is wrong. If it's continuous, differentiable, and there exists a c, that f prime equals c equals 0, then f of a equal f of b. This is not Rolle's theorem. Rolle's theorem, I have f of a equal f of b, then there exists a c such that f prime is c equals 0. This is like some kind of different than the Rolle's theorem. And this is wrong. For example, if you take a value a, and this is b, okay, let the function do something like this. This is f of a, then it will do like this, where I have c, then it will go back. Okay, so I have c where f prime, here I have f prime at c equals 0, and the function will do something different, will do like this. Who cares? So f of a is not equal to f of b. So this is wrong also. Said if f and g are increasing functions, then fg is increasing function. How I can say a function h, for example, f times g is an increasing function? If its derivative is positive. If I check the derivative, I have f prime g plus fg prime. Oh, okay. So it's not only when he said f and g are increasing, means f prime positive and g prime positive. So now this is positive. This is positive. I cannot conclude that h prime is positive since I don't know about f and g. Are they positive or negative? Because of that, this is wrong, not always true. He said if the graph function has 3x intercept, then it must have at least 2 points at which the tangent line is horizontal. It means there is 2 points that f prime at c equals 0. Okay, this is wrong. Why? Because the function is not continuous. If the function is continuous and differentiable, yes, that's true. For example, see this graph. I have 3x intercept, huh? Let me make it more, huh? 3 intercept, 1, 2, 3. I'll make a function not continuous, where it has no tangent line. This one goes, then stop here, then it started here, then do something, then stop here, stop here, then do something else here. No, it should reach the value. Okay, no problem. We'll make it here, doing something like this. Actually, the function should pass through these things. So it will pass through this, then stop here, then start from here, touch this, stop here, start from here, or start from there. No problem, from here, and do something like this. So it has 3 intercept, but it does not have tangent line horizontal, or he said at least 2 points. Actually, there is no point where a tangent line is horizontal, because there is no continuity. This one is true because what he mean horizontal tangent line means f prime at x1 equals 0. So how you can find x2? Because x2 would be x1 minus f of x1 over f prime at x1. We have a problem here. This is 0, so we cannot find x2. So Newton's method will fail. Okay. Now let us continue doing these calculations for different functions. Now the function is this one. I need to do the calculations. First, what's the domain? Domain of the function? Or real numbers. This is odd, huh? So it will be odd number. There is no restriction in x. I can put any value of x. Now we'll find f prime. F prime will be what? Product rule. So I have 4 x is minus 1 over 5 times x minus 1 square plus 10 x to the power 4 over 5 times x minus 1. So I'll take now common factor. I can take 2. X is minus 1 over 5 and x minus 1. What is the remaining? It's 2 times x minus 1 plus 5x. Yeah. Or we can check. Multiply this by this. You get what? 4 x to the power minus 1 over 5 x minus 1 squared. Okay. Multiply this by this. You have 10 x to the power 4 over 5 times x minus 1. خلاص. So now I have what? 2 x minus 1. And this is what? 5x plus 2x, 7x minus 2. Correct? Yeah. 7x minus 2 over x to the power 1 over 5. Okay. Critical numbers. I know f prime of x equals 0. So I have x equal 1 and x equal 2 over 7. Okay. And if prime does not exist, implies x equals 0. And all they belongs to the domain of f. So the domain of f is all real numbers. And last time I plug the numbers. This is 0. This is 1. This is 2 over 7. It should be somewhere. 2 over 7. Make it 2 over 7. Okay. And this is 1. And the rest. Okay. So take a value, and this is f prime of x. Take a value before 0. Take minus 1, for example. It will be negative, negative, negative. So that will be negative. Take a value between 0 and 2 over 7. For example, I take 1 over 7. It will be negative. Here I plug it. I have what? 1 minus 2, negative. This is positive. That will be positive. Take between 2 over 7 and 1. Take, for example, 3 over 7. It will be what? This is negative. The first one negative. This one 3 minus 2, which is positive, positive, so that's negative. Take more than 1, 2, positive, 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 so that will be positive. So it's decreasing, increasing, decreasing, increasing. Okay, and everything defined. How many local maximum, how many local minimum? I have this one relative minimum. This one relative maximum. And then this one relative minimum. So I said capital M relative maximum. So how many relative maximum? Have 1. And capital N relative minimum, I have 2. So this is 2 times 1 plus 2, which is 4. That's the answer. How many we have? Huh? I need to check f of 0, f of 2 over 7, and f of 1. And for sure, they are not the same. So, no need to worry. Okay, if x equal this, when this function is increasing. So, what's the domain first? Domain of f from 0 to infinity. Because I have this, and also x not equal to 0. So now we need to find f prime, product rule. That will be minus 2 x is minus 3 times ln x plus x is minus 2 times 1 over x. So that give me what? Minus 2 x is minus 3 ln x plus x is minus 3. So I take x is minus 3 common factor, and they have 1 minus 2 ln x. Or in other words, this is 1 minus 2 ln x over x cubed. Okay. F prime not equal to 0. So I have what? 1 minus 2 ln x equals 0. So I have 2 ln x equals 1. So I have ln x equal half. So x e to the power half, which is square root of e. Okay. If prime does not exist, x will be 0, which is not in the domain. So ignore it. So I have 0. This is my starting point. And I have square root of a up to the end. This is my number 9. Okay. Now, between 0 and square root of a, I want to take a value to check f prime. What is f prime? This is f prime. So let me write f prime somewhere here. F prime 1 minus 2 ln x over x cubed. Okay. What is the value between 0 and square root of a? I take 1, for example. 1 is less than square root of a. Take 1, what you will get? 1 over 1, so that will be positive. But after square root of e, I will take what? E, for example. It will be what? 1 minus 2, negative, over, so that will be negative. So when it's increasing from 0 up to square root of e, this here is increasing. Increasing from 0 up to square root of e. Another function, product rule. First, what's the domain? Domain Orion numbers. Very clear. So now we'll do the derivative. Half f prime will be what? Derivative of the first, which is minus e x minus 3. Derivative of this is minus 1, plus 3 minus x. Derivative of this, which is the same, ex minus 3, derivative of x minus 3, which is 1. So I have ex minus 3 as a common factor. I have what? Minus 1 plus 3 minus x. And that will be 2 minus x. 2 minus x, yes. That will be my f prime. I'll check f prime equals 0, implies x equal to false. So put 2. Okay. Before 2, check. That will be positive. Take a value 1. It will be positive. This is always positive, so no worries. After 2, take 3. It will be negative. You want what? Decreasing. Decreasing here. This is increasing. This is decreasing. So it's from 2 to infinity. Okay. The sum of all values of a in the interval in which the function has a relative extremum at x equal a. The relative extremum at x equal a on the x values where I have relative extremum for this function. Let us do the calculation. F prime. Once I have this, it's the first cycle. I have f prime will be 2 cosine 2x times minus sine 2x times 2. Okay. And that will be what? Notice this is minus 2 sine 2x cosine 2x. And this one is what? Is sine 4x. Okay. Double angle, huh? We know that double angle sine 2x is 2 sine x cosine x. So sine 4x which is sine 2 of 2x. It means it's 2 sine 2x cosine 2x, which is this. So that will be minus 2 sine 4x. Okay. I now f prime equals 0. We'll get what? Sine 4x equals 0. When sine 4x equals 0. That means I have 4x equal n pi, correct? Sine equals 0 when I have n pi. Am I right? Yeah, 0 pi, 2 pi, 3 pi, 4 pi, and so on. Okay, so x equal n over 4 pi. Okay, now we'll check which one in this domain. خلاص? So take n equals 0. I have what? X equal 0. Okay. Not in the domain. 0, not in the domain. This is out. N equal minus 1 will give me x equal minus 1 over 4 pi, which is not in the domain, and so on. This way. Now we're going the other way, in the positive way. X will be what? Pi over 4 is in the domain. N equal 2. X will be equal what? Pi over 2. It's in the domain. N equal 3. X equal 3 pi over 4. It's in the domain. N equal 4. X will be equal pi. It's in the domain. N equal 5. 5 pi over 4. It's in the domain. N equal 7. N equal 7. N equal 6. That will be what? 3 pi over 4. 3 pi over 2. 6 pi over 4, which is 3 pi over 2. Is also in the domain. N equal 7. N equal what? X, I mean. 7 pi over 4. It's in the domain. N equal 8. X equal 2 pi. This is not in the domain. This is out. N equal 9, and so on. All of this will be out. After that. So I have these 7 values. I want to add them. So the sum will be equal pi over 4 plus pi over 2 plus 3 pi over 4 plus pi over 4 plus 3 pi over 2 plus 7 pi over 4. Over 4 I have what? 1, 3, 4, 5, 1, 3, 5, 7. So I have 12 plus 4, 16. That will give me 4 pi. Over 2, I have this and this. So I have 4, that will be plus 2 pi. And there is plus pi. So the answer is 7 pi. Calculation, nothing to worry about it. Just you need to figure it out from here. The function is decreasing in this interval. Okay. Decreasing in the interval, this. What's the domain? All real numbers except half. We'll find f prime, product rule. 2x minus 1 minus 2x squared over this square. That'll give me what? 4x squared minus 2x squared, which is 2x squared minus 2x over 2x minus 1 squared. And these things will be what? 2x times x minus 1 over 2x minus 1 squared. Critical numbers, I have f prime equals 0. That give me x equals 0 or x equals 1. By the way, what is the point of discontinuity? X equal half. Very clear. Okay. So I'll put this one. I have 0, half, and 1. I want to check the sign of this f prime. Okay. Take a value, -1. It will be negative, negative, This is always non-negative or always positive, since I don't have x equal half. So that will be positive. Between 0 and half, we'll take a value between 0 and half. Take, for example, 1 over 4 will be positive, negative, so that will be negative. Between half and 1, I will take a value 3 over 4, 3/4. It will be what? Positive, negative, negative. That will be negative. And from more than 1, take a value +1, +2 will be positive, positive. That will be positive. So it's increasing, decreasing, decreasing, increasing. So it will be decreasing from 0 to half for sure. Notice I cannot say from 0 to 1 it's decreasing, huh? Because that half, it's not defined. Okay. I have this question. Okay. 2 more to finish the questions before we go to the questions from the book. If the function has a relative minimum at 0, 0, and the relative maximum at 2, 2, and he has 3 or 4 unknowns, you want to find the sum of these unknowns. Okay, I have 4, so I need four equations. When you say has a relative minimum at this point, so this point is point in the curve. It's pointing there. So I have from this, f at 0 equals 0. And not only that, he said has a relative minimum, it means f prime at 0 equals 0. Okay, this one, the same thing. I have f at 2 equal 2, and f prime at 2 equals 0, since I have a relative maximum. We know that if I have relative minimum, relative maximum, then f prime at c equals 0. So I have 4 different conditions, and I have 4 unknowns. Let us try to find them. F at 0 equals 0, that implies what? 0, 0, 0, 0 equal A0. I got A0. Let me find f prime. What will be f prime? 3a3x squared plus 2a2x plus a1. Okay, I have f prime at 0 equals 0. So that implies what? 0 equal, but take x 0 here, I have a1. So a0, a1, they are zeros. That will make it easier for me. So this is 0, this is 0. So I need just a3 and a2. Like f prime, f at 2 equal 2. That implies what? 2 equal 8, a3, okay, plus 4, a2, which implies I divide by 2. So I have 2a2 plus 4a3 equals 1. This is my first equation. Second equation, if at prime at 2 equals 0, equals 0. So I have 0 equal, this is 2. 0 equal f prime at 2, I have 12a3. Okay. a1 is 0, plus 4a2. Yeah, plus 4a2. So that implies what? I have 4a2 divided by 4. So I have a2 plus 3a3 equals 0. I need to solve these two equations. Multiply by 2 and this one. So I have 2a2 plus 4a3 equal 1. Here I multiply by minus 2. Minus 2a2 minus 6a3 equals 0. And you get what? Minus 2a3 equal 1. So a3 equal minus half. Plug it here. So I have a2 minus 3 over 2 equals 0. So a2 equals 3 over 2. So I have A2, I have A0, I have A1, I have A3. Add them, you get what? A0 plus A1 plus A2 plus A3. That will be what? 0 plus 0 plus 3 over 2 minus half. That gives me 1, which is this one. Okay, calculation. I think it's very clear. Just you construct these conditions and then do the calculations. Okay, this one, the function is increasing in this interval. I think it's an easy one. The domain Orion numbers. Let us do the calculations. F prime will be what? 12 minus 3x squared. In other words, it's 3, 4 minus x squared, or 3, 2 minus x, 2 plus x. I have minus 2, 2. Take a value before minus 2, minus 3. It will be positive, negative. That will be negative. Connect. Yeah, minus 3, it will be what? Positive times negative. Okay. Take a value to minus 2 and 2. Take 0. It will be positive. More than 2, 3, it will be negative times positive. That will be negative. We want what? Increase. Increasing from where to where? From minus 2 to 2. Okay. Now let me go to the questions from the book. I'll try to do them quickly. I think the section is very clear. Just every time we have a different function. Okay. Yeah. Let me start with the first one. He said in this exercise, use the graph to estimate an open interval in which the function is increasing or decreasing. From the graph and find it analytically. Okay. From the graph, very clear, it's decreasing from here up to there. So from the graph, 8, graph, decreasing, minus infinity to minus 1. And then from here, from 0 up to 1, this is decreasing also. And 0 to 1. Increasing from minus 1 to 1. Minus 1 to 0, sorry. Not to 1, to 0, up to here. It's up to 0. And from 1 to infinity. From 1 up to infinity, increasing. Analytically, or the calculation, the domain Orion numbers, خلاص. Domain Orion numbers. So I'll find f prime. That'll give me what? 4x cubed minus 4x. Take 4x. Label I get minus 1. 1. Take a value minus 2. That will be negative, negative, negative. That will be negative. Minus 1 to 0. Take minus half. That will be positive. Negative, negative. That will be positive. 0, take half. Will be positive, negative, positive. That will be negative. More than 1, positive. So it's decreasing, increasing, decreasing, increasing. So decreasing minus infinity to minus 1, and from 0 to 1, which is the same. Increasing minus 1 to 0, and 1 to infinity, which is the same. Okay, let me go to question number 10. I'll do it from the graph, then I'll do it analytically. Okay, from the graph, it's increasing from where to where? It's increasing up to here. Okay, increasing from the graph. Increasing from minus infinity up to 0. Okay, and increasing from here up to the end. And 1 to infinity. Okay. Decreasing. This is what? I think this is x equal half. So it's decreasing from 0 to half. And half to 1. Also here is decreasing. Okay. Now analytically, okay. What's the domain of the function? In a very clear domain of f, all real numbers except half. Okay. We'll find the derivative. What will be the derivative of f? It will be 2x times 2x minus 1 minus 2x squared over 2x minus 1. That give me what? 4x squared minus 2x squared, 2x squared minus 2x over 2x minus 1. I can take 2x common factor. I have x minus 1 over 2x minus 1. So this f prime equals 0. It gave me x equals 0 and x equals 1. Or x equals. Answer root number 9. I have what? 0, half, open, and 1. Okay. Before 0, take a value negative. You'll get what? Negative, negative. No, it will be take a value before 0. It will be, yeah, this is square. Huh? Don't forget, this is square. This is a square. This is a square. Yeah. But the quotient rule, square the denominator. Okay. Take a value before 0 minus 1. It will be negative, negative. This is always positive, so no worries. So that will give me positive. So 0 and half, I take 1 over 4, for example, it will be positive, negative. That will make it negative. 3 over 4, also it will make it negative. More than 1, it will be positive. So it's increasing, decreasing, decreasing, increasing. So increasing from minus infinity to 0, 1 to infinity, which is this one. Decreasing 0 to half and half to 1, which is this one. So it's correct. The graph and the analytical calculation are the same. Okay. In terms of which the function is increasing and decreasing. Just here, give us functions. You want to find, we need to find when the function is increasing, when the function is decreasing. Different functions. So different calculations. Okay. Here the domain of numbers. Let me do it step by step. Okay. Number 12. And let me write the function again. Okay. So I have the domain or real numbers. Find h prime. It will be 12 minus 3x squared. I take 3, 4 minus x squared, which is 2 minus x, 2 plus x. Okay. What are the critical numbers? H prime equals 0. That means they have x equal plus or minus 2. So these are the numbers which I will put them there. This is minus 2. This is 2. Before minus 2, take a value, minus 3. That will be positive, negative. That will be negative, positive, negative. So it's decreasing, increasing, decreasing. So I can conclude increasing from minus infinity to minus 2. Oh, no. From minus 2 to 2. Increasing minus 2 to 2. And decreasing minus infinity to minus 2. And 2 to infinity. Okay, we'll do the next function, 13 y equal x square root 16 minus x squared. First, I need to find out the domain. What's the domain of this function? Domain of f. I need 16 minus x squared, positive and negative, means x squared less than 16, means absolute value of x less than or equal to 4. So x between minus 4 and 4. So this is my domain, minus 4 to 4. This is what I will concentrate in this interval. We'll find y prime now. Product rule, x is 1, square root 16 minus x squared minus or plus x times, this is 2 square root 16 minus x squared, derivative of this, which is minus 2x. So that will be what? 2 cancels with 2. Let me take common factor. That gives me 16 minus x squared minus x squared. That will make it what? 16 minus 2x squared. So I can take 16 minus 2x squared. I can take 2 common factor. And I have 8 minus x squared over this. Okay. So f prime equals 0. So I have x squared equal 8. So I have x equal plus or minus 2 square root of 2. And I have f prime does not exist. Implies x squared equals 16. So I have x equal plus or minus 4. So this is what I will include. Actually, starting from minus 4 to 4. And I have here minus 2 square root of 2 and 2 square root of 2. Okay. I need to check the sign for f prime. This is my f prime. Okay, this is always positive. So I care only about 8 minus x squared. Okay, I take a value here, minus 3, for example. Substitute, it will be 8 minus 9, that will be negative. Here I take 0, easy one. Take 0, you have what? Positive. Here I have 3, it will be negative again. So it's decreasing, increasing, decreasing. So it's decreasing, or let me say increasing. Let me just make it like this. From minus 2 square root of 2 to square root of 2. And decreasing minus 4 to minus 2 square root of 2 and 2 square root of 2 to 4. Okay. As you see, now we have the same idea but different functions. Now I have y equal x plus 9 over x. What's the domain? All real numbers except 0. Okay. This is the domain. We'll find y prime. Y prime will be what? 1 minus 9 over x squared. In other words, this is x squared minus 9 over x squared. Okay. Which is y prime equals 0. I have x equal plus or minus 3. So I have minus 3, 0, open, point of discontinuity. 0 is a point of discontinuity. Oops. Point of discontinuity is 0. And this is 3. Okay. This is not. Okay. Take a value between minus. This is non-negative, huh? Take a value -4 here. It will be positive. -3 and 0. Take -2. It will be negative. 0 to 3. It will be negative, and that will be positive. Okay, so this is increasing, decreasing, decreasing, increasing. Huh? So we say increasing. This is what 14. Okay, increasing. Minus infinity to -3 and 3 to infinity. Decreasing, I cannot say for -3 to 3. Be careful. It's from -3 to 0 and 0 to 3. Because it's not defined as 0. So I cannot say it's decreasing from -3 to 3. Huh? Okay. Different functions. Now cosine 3x over 2. But he gave me a specific interval. Okay. 16. So I will do the derivative. F prime will be what? Will be -3 over 2 sine 3x over 2. Okay, critical numbers. Need to find f prime equals 0. So I have 3x over 2 equal n by. In other words, x equal 2 over 3 n by. Which is, what are the values? I have at n equals 0, it's 0, not included. At n equal 1, so the values are 2 pi over 3. And x equal, n equal 2, 4 pi over 3. N equal 3, it will be 2 pi, which is not included. These are the two values. So plug it. I have 0, open, and 2 pi, open. These are not included. And they have 2 pi over 3 and 4 pi over 3. Here, take a value for this function. Take a value between 0 and 2 pi over 3. Take a value, for example, pi over 2. Pi over 2, what you will get? You will get 3 pi over 4, which is in the second quadrant, so sign is positive. That will make it negative. Take a value between 2 pi over 3 and 4 pi over 3, or take pi. 3 pi over 2, sign is -1, so that will be positive. Between 4 pi over 3 and 2 pi, I take, for example, 5 pi over 3. If we take 5 pi over 3, you have 5 pi over 2. Sine 5 pi over 2 is first quadrant, so it will be positive, and the -3 over 2, that will be negative. So it's decreasing or increasing. Let me say we start with increasing 2 pi over 3 up to 4 pi over 3. And decreasing from 0 to 2 pi over 3 and 4 pi over 3 to 2 pi. Okay. Let me do the second one. He gave a specific domain. Okay. So we'll find y prime. Y prime will be what? 1 minus 2 sine x. Make it equal to 0. So I have sine x equal half. When sine x equal half, I have x equal what? When sine x equal half, half is pi over 6, 30 degree, which is the first and the second quadrant. So I have x equal what? When sine x equal to half. Oh, wait a minute. This is -2 cosine, so this is plus, sorry. So this is minus half. Yeah, be careful calculations. 1 cosine is minus sine, so it will be 1 plus 2 sine x, so I need minus half. So minus half where? Which quadrant? Third and fourth quadrant. Third and fourth, pi over 6, so it will be 7 pi over 6. And 2 pi minus pi over 6, which is 11 pi over 6. Okay. Now, this is 0, open. This is 2 pi, open. And I have 7 pi over 6 and 11 pi over 6. Okay. Take a value between 0 and 7 pi over 6. I will take pi, for example. This is my function, huh? F prime is what? Let me write it here. It's 1 plus 2 sine x. It's 1 plus 2 sine x. Okay, I need to check the sign of this function. So the effect here with sine. Huh? With 7 pi over 6, take a pi, it will be, so that will be positive. Okay. Take a value between 7 pi over 6, 11 pi over 6. I'll take what? 3 pi over 2. Who cares? 3 pi over 2 sine is what? Minus, so that will make it negative. Take a value between 11 pi over 6 and 2 pi. Yeah. I know this is which quadrant? Second quadrant. And at 11 pi over 6, sine is what? Minus half. And it's going to 0. So it will be a value between half and 0 with the negative sign. So this will be positive. So it's increasing, decreasing, increasing. So I have increasing from 0 to 7 over 6 and 11 pi over 6 and 2 pi, decreasing from 7 pi over 6 to 11 pi over 6. Okay. Now we'll do the next one, 22. What's the domain of f? 22. Domain of f is, I have what? X is positive and x is positive. So x is positive. Is the domain. We'll do f prime. Yeah. Need to be careful with f prime. It will be derivative of the numerator, which is 1 over x. So I have square root x over x minus the denominator, which is going to be what? Ln x over 2 root x, all of the denominator square, which is x. So you have what? You have you have 2x. Okay, let me write it here. 2x minus x ln x over 2 x 3 over 2 x. That give me what? Let me write it here. That give me what? 2x minus x ln x over 2 x to the power 3 over 2 times x. I can take x common factor. I have 2 minus ln x over 2x to the power 3 over 2. Okay. So critical numbers, I need to check f prime equals 0. So that implies ln x equal 2. So that implies x equal e squared. That will be my critical. Okay, so I plug it now, starting from 0. And this is e squared up to infinity. Take a value. Take what is my f prime? This is my f prime. Take e square, e for example. I have 2 minus 1, that will be positive. Take more than e squared. Take e cubed, for example. Let's say len e cubed 3. 2 minus 3 is negative, so that will be negative. This is always, since the value are positive, this one will be positive. So it's increasing and then decreasing. So increasing from 0 to e square and decreasing from e square to infinity. Okay. Now we'll do 18. As I said, I have these 3 examples. Just we have different functions. Need to do calculations for different functions. Let me try to do it quickly. We have an interval, so the domain 0 to 2 pi is given. So I have f prime 18. F prime of x will be what? 2 sine x cosine x. 2 sine x cosine x plus cosine x. We take cosine x common factor. You have 2 sine x plus 1. Okay. I write it here so I have more space. Now h prime equals 0. So I have cosine equals 0 or cosine x equal minus half. Okay. When cosine x equals 0, I have here x will be first quadrant, that will be pi over 2 and 3 pi over 2. Okay, from here, I have x equals 7 pi over 6 and 11 pi over 6. Okay, let me plug the numbers now. I have 0 and 2 pi. Okay, this is pi over 2. This is 7 pi over 6. This is 3 pi over 2. This is 11 pi over 6. This is 2. Take a value, 0 pi over 2. Don't forget this is your f prime. Huh? 0 first quadrant, that will be positive. That will be positive. So that will be positive. Very clear. 10 pi over 2 and 7 pi over 6. I'll take pi. That will be positive. That will be negative. Cosine pi is minus 1. Take a value between 7 pi over 6 and 3 pi over 2. Yeah, you can take it as degrees and then conclude just to save time. That will be positive. That will be negative. That will be positive. Take a value at each period. We can convert those to angles or to degrees. Huh? So that will be what? That will be 210. Huh? And this one 270. So you can take, for example, what is 240, for example. You can conclude 240 is what? Sine is square root 3 over 2 minus square root 3 over 2. And that will be negative, that will be negative, so that will be positive. Here you can take, yeah, 11 pi over 6 is what? It's 360 minus 30, so that's 330. So I can take, for example, 300. 300, I know sine is what? Minus square root 3 over 2. So it will be minus square root of 3 plus 1. That will be negative. And cosine is positive, fourth quadrant, so that will be negative, and so on. Okay. So increasing, half increasing, 0 to pi over 2, 7 pi over 6, 3 pi over 2, and 11 pi over 6 and 2 pi. This is increasing. Well, decreasing pi over 2 and 7 pi over 6 and 3 pi over 2 and 11 pi over 6. Okay. Let me do the next one. As I said, we have the same thing. The domain here are real numbers, nothing to worry about. So I'll go to G prime on us. G prime will be what? It will be minus e is minus x plus 3 e 3x. Okay. How to solve this equation? As I said, now we'll deal with different functions. We need to deal with different ideas. I can take e minus x as a common factor. Let me see what will happen. I have minus 1 plus 3 e plus e to the power of what? I take e minus x, e to the power 4x. Correct? Multiply that minus e minus x plus 3 e to the power 3x. Okay, I want this equal to 0. This one cannot be 0. It's impossible to be 0. So I have 3e4x equal to 1, or e4x equal 1 over 3. Take ln. I have 4x equal ln 1 over 3. So x equal 1 over 4 ln 1 over 3. Or in other words, since this is 3 to the power minus 1, that will be minus 1 over 4 ln. So this is my critical number. Critical number. Okay, خلاص. And e to the power cannot be 0. خلاص, nothing to worry about. So we'll plug this. I have minus 1 over 4 ln 3. That's it. This is what I have. I had to check before that. 4 minus 1 over 4 ln 3. I want to check this function. Huh? Notice f prime. Let me write f prime in front of me. So I have e minus x times minus 1 plus 3 e4x. Okay. Now to check this. Okay. This is always positive. Nothing to worry about. Here, I can take 0 in this side. Huh? Easy. Take 0. That will be what? If you take 0, you have 3 minus 1, which is 2, which is positive. So this is positive. Yes. Here I take which value? I take, for example, minus 1 over 4 ln 3, ln 4. For sure, here I have minus 1 over 4 ln 4. Okay. Plug it, I have minus ln 4, which is ln 1 over 4. So I have 3 over 4 minus 1, that will be negative. So that will be negative. So it's decreasing, decreasing from minus infinity to minus 1 over 4, then 3, are increasing minus 1 over 4, then 3 to infinity. Yeah, the only problem is here. You take this value, I think you can figure it out easily. And it's a negative internal. Okay, now we'll go to 20. What's the domain? Domain of f, x is positive, then negative. X can be 0. So we'll do H prime. H prime will be what? Product rule. I have is minus X over 2 root X minus is minus X over root X times root X, not over. Yeah, product rule. Derivative of the first, 1 over 2 root X times the second. Okay, plus the first derivative of the second, which is minus is minus X. Yeah, let us do it this way. I can take is minus X common factor. So I have what? 1 over 2 root X minus root X. And that will be what? 1 minus 2x over 2 root x. Okay. Yeah. Or in other words, 1 minus 2x over 2 root x e to the power x. That will be the function. Okay. Yeah. 1 minus 2x over 2 root x. Okay. Yeah, critical numbers. H prime equals 0. X equal half. Very clear. H prime does not exist. I have x equals 0. Actually, the domain is starting from 0. So this is 0. This is half up to infinity. This is what I'm looking for. 0 to half will take a value 1 over 4, for example. By the way, all of this is positive. Huh? All of this is positive. No worries. Or non-negative, let me say. Yeah. So nothing to worry about. Just I worry about 1 minus 2x. Take a value 1 over 4. It will be negative. 1 over 4, it will be what? 1 minus half. No, it will be positive. Okay, so yeah. More than half, take 1, it will be negative. So increasing from 0 to half and decreasing from half to infinity. Okay. Yeah, now we'll do more derivatives. Now, the first derivative test for different functions. And then we want to do both first derivative and decreasing for different function. Okay. Yeah. Then we'll do some different questions. Okay. I think I will stop here and then we'll continue later. So just let me stop the recording. Stop recording. Thank you.